This problem is from homework number 6, problem 6.35. So it asks you to find node voltage V1 and V2. Here we need to apply nodal voltage analysis. Let me change color. We need to apply nodal voltage analysis. First, we need to list the equation. So since the bottom circuit connects to ground, so it is 0 volt, and we're able to write equations. So we have we look at node 1. So this is node 1. This is node 2. So what we have is we can define the current flowing into node 1. So it is 0. So applying KCL. KCL at node 1. KCL at node 1. So we have node 1. We have what? 0 minus V1. 0 minus V1 divided by J50. And plus, because we have the 3 angle 5-degree current source flowing into V1 or flowing into node 1. So we can write plus 3 and angle is 5-degree plus, and the current flowing from node 2 to node 1. So we have V2. We have V2 minus V1 divided by minus J60 equals 0. Okay, and this is our first equation. And then we look at KCL at node 2. So node 2. So we have this so node 2 we have current flowing from bottom to top. We have 0 voltage minus V2 divided by 30 and plus there's a current source 2 degree 30 degree plus so we need to look at the current from node 1 to node 2 now. So we have this is V1 minus V2 divided by minus J60 degree equals 0. So we have these two equations. And we also need to convert the phasor of the current source into rectangular form. So we have so 3 degree 5 equals 3 cosine 5 degree plus J3 sine 5 degree, which is 2.989 plus J and 0.261. 261. Okay, and 230 degree equals 2 cosine 30 degree plus J 2 sine 30 degree equals 1.732 plus J. Okay, so we put this rectangular form back to this equation 1 and try to rearrange it a little bit. So we have minus V1 divided by J50 plus V2 minus V1 minus J times 60 equals minus 2.989 minus J 0.261. All right, and the second equation becomes minus V2 divided by 30 plus V1 minus V2 divided by minus J60 equals minus 1.732 plus J. So, the first equation, we multiplied everything by minus 300 J. Okay, so it becomes 6 V1 plus 5 V2 minus 5 V1 equals minus 2.989 times minus 300J minus J 0.261 times minus 300J, which equals minus 78.3 plus J 896.7. Okay, this is the first equation. And second equation, we multiply by minus 60 J. So minus J60. Okay. J60 or 60J, either way works. So yeah, time multiply minus 60J. So we have 2J V2 plus V1 minus V2 equals minus 1.7732 times times 60J, minus 60J. So we need to minus 60J. So times minus 60J minus 60J plus J times minus 60J, which is 60 plus J 103.92. Okay, so for this equation, you have to list the correct equation first, and then we are able to rearrange this. So let me turn to the next page. So when we rearrange this, we're able to receive this equation, V1 plus 5V2 equals minus 78.3 plus J 896.7. And we also have V1 plus minus 1 plus 2J V2 equals 60 plus J 103.92. And this could be solved by using Cramer's rule. Or if your calculator, I'm not sure if a calculator can make this, or you can define, a matrix A as 1, 5, 1, minus 1 plus 2J, and you define matrix B as minus 78.3 plus J 896.7, and the second element is 60 plus J 103.92. Because this equation equals AX equals B. Suppose we have X is a 2 by 1 matrix. Suppose X is V1, V2. Okay, so to solve this, we just need to multiply both sides with the inverse of A. So we have AX equals A inverse times B. So A inverse times A equals a unit matrix. So we have X equals A, the inverse of matrix A times B. So I'm not sure if your calculator can work on this, and then try your calculator. If your calculator can work on this, then it saves you a lot of trouble during the calculation. So, but if your calculators cannot do this, you can only apply by Cramer's rule. So in the end, we can find out V1 and equals I'm converting to its rectangular form. And angle is arctangent. This is on the in the first quadrant. So which is 404, 404.2, and angle is 56.2 degree. And this is volt. This is V1. And V2 equals 60.38 plus 112J. So this is 60.38 squared plus 112 squared. And we have arctangent. This angle is arctangent 112 divided by 60.38, which is 127.2 degrees, 62.3 degree. Okay, this is V1 and V2. And actually, and the answer is correct because I put V1 and V2 and I plug in back to the equation to double check. So because to calculate this complex number, it's very easy to make mistake. So please be careful during your calculation. Okay, and we look at our last problem. It's also in the homework. It's problem number 6.14. It asks you to find a phasor for the sinusoid voltage V1 and V2. And some of you may know. So V1, so the phasor V1 just because it has the amplitude 156, the angle is 60 degree, and the unit is V because a phasor is derived from cosine function. Okay, and as for V2, we need to convert sine to cosine. So same thing here, we result to this plot. We have cosine theta pointing to the right. We have sine theta pointing to the bottom. And then for the remaining direction, we just, the opposite direction of cosine is minus cosine theta. the opposite direction of sine is minus sine theta. So this is minus sine theta. And then since we need to convert sine to cosine, we start from cosine. So cosine goes to sine, we need to minus 90 degrees. So we have this formula. So this is the first equation, first answer. So we have formula cosine theta minus 90 degree. Right. Whoa, wait a second. Okay. Theta minus 90 degree is sine theta. And then if we make that theta equals 120 pi t minus 45 degree, which is here. And so we have cosine 120 pi t 120 pi t minus 45 degree minus 90 degree equals sine 120 pi t minus 45 degree. And so which is cosine 120 pi t minus 135 degree. Okay, so therefore the phasor V2 equals the amplitude remains the same. Let me rewrite this. So actually, so V2T becomes the amplitude remains the same, but sine becomes cosine, and 120 pi t minus 135 degree. So the phasor of V2 equals its amplitude 220 and its phase is minus 135 degree, and the unit is volt. So this is how we convert sine to cosine, and in order to write down its phasor representation for sinusoidal function.